Please welcome Amanda Silver.
Hello, world. I'm Amanda Silver. I'm delighted to be here today on this beautiful day in sunny San Francisco at the GitHub Universe conference, the conference that is by and for developers. So today we're going to build an intelligent app from scratch and deploy it to production. And I really just want to kind of jump in really quickly. In 2021, we launched Copilot as the world's first AI pair programmer. And last year at Universe, we added model choice and we used the word agent for the first time. And we've been really pushing the frontier of AI across multiple modalities, advancing the state of the art in machine learning to make Copilot more helpful and more intuitive for you, and more powerful. And what we're seeing is that in agent mode, with GitHub Copilot Coding Agent, it's really driving up engagement and productivity. And in fact, 80% of new developers on GitHub now use Copilot within their first week, showing that AI is becoming an absolutely essential part of the developer experience. Developers are using Copilot right in their code editor so that they can stay in the flow. And our goal is to make it so that Visual Studio Code becomes the AI native code editor. And earlier this year, we open sourced the Copilot chat extension, and today you saw what's next. The agent session views, bringing you custom local and remote agents, codex agents, and planning mode. And all of these tools together are making GitHub Copilot essential for building cloud-native applications. So with that, let's build an app. Modern apps are cloud native, they're agentic, they're self-improving, and they're kept low maintenance by specs that define, generate, verify, and operate the systems. Specs become the single source of truth that agents, pipelines, and platforms follow, turning your strategy and your implementation recommendations into repeatable, auditable automation. I really love this quote from Andrea Griffiths from GitHub. Give a dev a code completion and they'll merge once. Teach a dev to wield an AI coding agent and they'll empty the backlog before the coffee cools. So I'd like to welcome Shayne Boyer on stage to show us how he uses Spec Kit and all of the MCP tools that we're bringing to our experience. Shayne? All right, let's get to it.
Let's get to it. Now, the one thing that has to work is my fingerprint. Okay, that works, great. So here we've got our Octopets app. It's our new AI native version of Octopets that we've been working on. And what we have here is we've got a great kind of AI native, very clean app that we've been working on here. And we've got some cool little features. We've got our great little rabbit mill.
Yeah, he had to do that. That's my bunny.
You're welcome. All right. So what we used in order to develop this app is, as you mentioned, some Spec Kit-driven development or specification. And this is our open source project we've been working on with GitHub here to do some spec-driven development instead of just kind of vibe coding our way to hoping we're getting something that we're looking for in an app. So let's jump over into VS Code and see how we did this. Now, Spec Kit is a great way for us to just kind of define what we want to build in an app or a feature. And one of the latest features we have here is when we run the Spec Kit, we get these great little quick clicks to get what we need. Now, what I want to start with here is the Constitution is kind of our governing principles around what we want to build into our app and these guiding guidelines for what we're building.
So they're kind of like your best practices, but then you can also share them with the team.
Yeah, I love it because it's kind of a template, but it also kind of sets, again, the principles of what we're trying to build without having to put a lot of stuff into our prompt, right? So what I want to make sure is that we are going to be deploying this to Azure eventually, so I'm setting some guidelines here. So right out of the gate here, you'll notice that I am going to be using the Azure CLI. I'm going to be using the Azure MCP and making sure that I'm getting those best practices for code gen around those components that I might be using when the prompt gets put into Spec Kit. I'm also making sure that if I have any agent-driven stuff that's going on, any models that I want to be using, that I'm using the Azure AI Toolkit MCP tools, and I'm getting those best code gens too.
Now, Spec Kit isn't specific to Azure.
No.
If I was using a different cloud, I could actually specify what I wanted to do.
Sure,
for that
you can
cloud as
just,
well.
if you have any MCP tools that you want to use, I can just put those right here in my Constitution file and making sure that when I run my prompt, those will be invoked. And I'm going to put some other things in here too. I'm going to be using aspires, other principles that I want to make sure get invoked. So when I run the actual specify command with my prompt. If I want this Airbnb style app for octopets, make sure that you're following these things there. Now, we did that already. Obviously, we've got some time constraints. We want to make sure we do this fast. That we are already going to get our user stories generated by the specify command, which is great. So this is really cool. Make sure it generates all of our user stories that we're looking for based on our prompt of, give me an Airbnb style app for our pets. Really great.
So it kind of expanded from your single prompt
Right.
into user stories,
Right.
and then you're working from there.
Yeah, I mean, I could go into a sandwich shop and say, give me a sub, and hope I'm going to get a sub. Or I can say, here's all the things that I want, and it's going to give me a much better result, right? Same idea. Now, the next one I can do is I'm going to go ahead and do a plan right here where when I do the plan, I could actually put in, I want to use the Azure MCP, I want to put in Aspire, or maybe I want to use React and put that in here too. But since I've already put that in there, I could just say, follow my instructions that I put in the Constitution and give me the results.
Right.
And that's exactly what it did. So when I look at the actual plan that gets run here, let me go over and look at those results here. We did our plan summary. You can see that we go to the top, it planned out everything, gave us our feature overview, the technical content. It did have a couple of things that it needed some key decisions on. We put that in there, which was really good. And it generated all the files that we needed as far as our plan and research. Now, what was interesting here is when we look at the research file, and if I can just open the preview here, let's just make this a little bigger, we can see that it did actually follow these MCP tools that we were looking at, and it gave us our model recommendations, because we know we're going to be using agents for maybe a chat feature or some other recommendation things. And it says, look, use GPT-4 Mini, which is great. It gives us some options around maybe what we're going to do if we're going to put it into Azure AI Foundry for production, and also gave us some alternative considerations. So it did invoke those MCP tools as we expected as we generated our plan. Now, the final thing that we want to do is now turn that plan, that research, and that spec into some individual tasks. So when I run the task mode, it'll take all those things into consideration and generate the individual steps that we need to actually run for specify to do, right? So when we run the tasks, it'll say, look, I'm going to read all the things that we've generated as a part of our prompts, which is really good. And then we scroll down here, and it's broken up individual phases that we have going here. Now, if I want to look at the actual tasks that were built, again, it's just a lot of individual steps. If everything has to do, here's my front end and all that.
That's a lot of manual, tedious work that you have to do to
I don't want
translate
to have
it
to
into
do all
every
that
layer.
work, right?
Yeah.
So what I actually did is I took advantage of another MCP, the GitHub MCP. All right, and I said, hey, friend, can you create issues in my repo for each one of these tasks? This invoked my GitHub MCP, which if I look at my GitHub task here, it created issues in my repo for each one, which is really cool. The better part of this is I can actually go over here and I can assign this to my coding agent. It's going to kick off that create backend for me while maybe I'm doing some front end stuff. I know I'm not going to do it. I'm just going to assign it to another agent to do that work as well. And then we can see those things being created. It's going to check them off one by one as I'm moving forward. So I'm taking advantage of MCPs. I'm staying inside of VS Code and having all that do the work for me.
Awesome, Shayne. Thank you so much.
All right.
Cool. All right. So Spec Kit brings spec-driven development to coding agents with tools like GitHub Copilot. Even it also supports Claude Code and Gemini CLI. So even if you're not using GitHub Copilot, you could also use it with those tools as well. And what it does is it turns the specs into these living executable artifacts that guide and evolve and break down all of the work, just as Shayne just showed you. And he also showed you the Azure MCP server, which we're actually announcing today is GA. It securely connects Azure services with AI tools like GitHub Copilot, giving you that real-time data about your resources, allows you to do the resource management, do infrastructure as code, and all of the troubleshooting, all through prompts in your IDE. And it makes it much easier to build and manage and deploy your cloud-native applications on Azure without having to hunt and peck through the portal. So we've got our app up and running, as we just showed you. Now let's turn to adding intelligence and automation to it. You know, AI agents aren't just another application. they really play by different rules. Traditional apps are built on fixed logic, and they're updated manually. They follow really rigid, predefined steps and control flow, and you have to manually describe the infrastructure. AI agents work on probabilistic models, not static control flow. They reason, they plan, they adapt as they go. They are adaptive by design. And you focus on the intent, and what you build is the signal loops and the guardrails, not just the endpoints. So to show you what I mean, I'm going to invite Rong on stage. And for all of you, you might have been using agents for months now in your development flow, but you're not necessarily familiar with how to build agents quickly, so that's what we're going to show you. So welcome, Rong.
Hello, everyone. All right, let's build an AI agent.
Let's do it.
All right, the first thing I'm going to need is a great model, because models are the foundation for powerful agents. I can come over here to the AI Toolkit's model catalog to explore different models, including those that we can deploy to the AI Foundry service with a single click, or we could download a local model with a single click as well. Either way, I can then hop over here to the model playground to test out each model's capabilities. But at this point, I still don't know which model would be great for my agent. So I'm going to come here and ask Copilot for advice. I'm going to say, which Foundry models do you recommend for a sitter agent that I want to build that can suggest pet sitters in the area? So we see here, Copilot is calling the AI Toolkit tool for the latest model information. And now, considering the agent that I want to build, Copilot is giving me a few model options with very detailed information about its cost, context window, and use cases each model is for. So with that information, I can make a model choice really, really fast. So it sounds like the top model Copilot is recommending is GPT-4o. So I think we're good to give that a try. Now let's build an agent. And again, I'm prompting Copilot to help me with that, to create an agent.
So you might have never have built an agent before, right?
Right.
And this is actually going to allow you to just input that as a prompt and then...
Yeah, create a full-fledged working agent right here.
All right, let's see it.
Yeah, this is, again, using the AI Toolkit's tool. And we can take a look at this code that Copilot generated for us. We are using the new Microsoft Agent Framework that allows us to write single agent or orchestrate multi-agents really, really easily. Down here, we can see the definition of my agent. Right here is my system instructions and a list of tools that Copilot created for me. I even asked Copilot to turn on, to enable tracing for my local runs so we can observe how exactly our agent is performing. So with that, let's turn on a local trace collector.
All right.
All right, let me move this up so we can run this agent
Your mouse
here.
right there you go.
And test out. All right, or without tracing, but we can at least
there you
test
go.
out. Yeah.
There you go.
So our agent is running. So let's look for a dog sitter in San Francisco area. And what's happening here is our agent is making a call to the model endpoint that I have in Foundry. And it's going to look for the right tool to call, and then come back with the right information about our sitters in the area. Great. And in the meantime, we just received a trace that was collected as part of our run, and we can see the model call to the GPT-4o model, a 4.1 model, and a tool call as expected. Awesome. So now we have a single agent created, and I did the same thing for another agent for recommending pet venues. Okay. Now I wanted to scale up. I want to orchestrate both agents into a workflow. So again, I come back here to Copilot to help me with that. So Copilot can not only create single agents, but can orchestrate multi-agents as well. Let me get to the top of this. And this is the prompt I sent to Copilot. And let me get this visualizer up running. All right, let's get the workflow started. Now we are starting a listing agent and a sitter agent, both on my local machine, and the workflow is being kicked off. We're testing a few user queries. We're seeing each agent, sometimes both agents are going to be invoked as part of this workflow.
Got it.
And if we take a look at this code generated by Copilot, it is using the Microsoft Agent Framework as well. But this time, instead of a single agent, it is using a workflow builder so we can orchestrate multiple agents together. All right, so now we have vibe checked a few user queries. Things are looking good. But we want to do a more broader assessment of the quality of agent responses. So it might be a good idea to put an evaluation in place.
Yeah, so evaluations are kind of like unit tests, but for stochastic processes, right?
Right.
So that I could actually kind of check the performance kind of to see if the agent is doing what I expect it to do.
Right, exactly. So again, coming back to Copilot, you see where this is going. Everything, I'm relying heavily on Copilot to do the job for me. I simply said add evaluation to my agent, and that is all of my prompt.
So you don't need to know anything super specific about the evaluation framework per se.
Yeah, and
Awesome.
I don't have a metrics defined, I don't have a test data set, but that's fine, because Copilot is going to guide me through that whole process. It looked at everything in my workspace and suggested metrics I can use, and even went ahead to generate test data for me, which we can view right here in Data Wrangler. This is a list of user queries that's generated by Copilot that is relevant to my agent use case. So with that data and this Python script that Copilot generated for me, powered by the Azure AI Evaluation SDK, I can now run evaluations offline on my local machine. Or I can integrate this with GitHub Actions. So I can have evaluation run triggered as part of my CI/CD pipeline on every commit. So I can see my results here. All right, with all that work done, evaluation in place, I have confidence to check in my changes. Finally, let's see that in action, and let's test this out in our application, see if everything works. All right, I'll come over to the chat, and I am going to ask for a cafe and a sitter recommendation in the San Francisco area for next week, since we're here, and I do have a budget limit of around $30. So we'll see if the team of agents behind this chat experience is gonna give us good recommendations. This kicks off a workflow that involves 2 agents calling model endpoints. All right, so we got a response back. Looks like there's a number of good pet-friendly cafes in the area. And our agent is also telling us there are no sitters available under my budget. So I guess we have to bump that up to a higher number.
All right.
And yeah, great. So our agent is able to find someone who charges $40 an hour, and now I have a sitter.
Got
Perfect.
it.
All right.
All
yeah,
right.
that's what I want to show.
Thank you, Rong. Thank you. All right. So what she just showed you was the AI Toolkit for VS Code, and it really helps you do that generative AI development. It helps you embed models and workflows directly into your developer inner loop, and so you can discover and explore local or remote models. You can author and evaluate agents and multi-agent workflows right in your IDE, and then integrate them seamlessly into your AI applications, and ultimately deploy them to Azure and AI Foundry with a unified VS Code and GitHub Copilot experience. Now, she also showed you there the agent framework, an open source toolkit to build, wire up, and level up AI agents, and it really blends the best of semantic kernel and autogen into one flexible runtime, so you can prototype locally and experiment across the clouds without having to rewrite everything. Now, today we are announcing a public preview of the GitHub Copilot prompt-first agent development. So you don't need to actually know a ton about all of these new frameworks to be able to build them in your application. And then she also showed you the Azure AI agent evaluation, and the Azure AI evaluation with the GitHub action. And so that allows you to both test your AI agents locally as you're doing your local development in your inner loop, but it also allows you to actually deploy them into your CI/CD loops as well, so that you can catch those issues and improve the quality before deploying to production and so on. And so that supports both single agent and multi-agent comparisons, and it's really easy to install directly from the GitHub Marketplace. So somebody's super excited about that in the audience. So the app is live, which is great, but most incidents still take hours to resolve. It really slows your recovery, it slows your time to remediation, and it ties up your SREs with these really routine fixes. And so today, a ton of operational issues require an on-call engineer to spend hours investigating and remediating a single incident, and that slows down your time. It slows down your MTTR. So we've spent a lot of time listening to SREs and training our own, and we understand the pressure that they're under. It's a really high stakes, high pressure situation where your site is down, there's a lot of pressure on you, and how do you actually resolve it? You know, you have to reduce your overall time, you have to improve your time to remediation, and ultimately we know that it kind of is not awesome to be a dev that's on call, that gets woken up in the middle of the night to deal with a live site incident. So what we're looking for is a solution that gives you less toil, fewer 2 a.m. alerts, and really more time to focus on being a meaningful engineer. What if you actually had a super knowledgeable IT person who never sleeps, is available 24/7, can instantly analyze thousands of system metrics and logs, can automatically fix the common problems that you have in your solutions without sometimes needing human intervention? And so what I'd like to show you is to bring Shayne back on to show us how he's using the Azure SRE agent as a really super knowledgeable agentic partner. Shayne?
What is?
Let's do it.
All right. Who likes to get woken up in the middle of the night to fix something? Yeah, one person.
Night owl.
Night owl. All right. I want your phone number. I'll call you. All right. So here we've got our SRE agent. We've deployed our Octopets app. Rong came out and built some agents to implement all that stuff. So now we have to make sure that if it breaks, we don't call him. All right. So we've got this all set up here, and this works a lot like a Copilot agent, right? I can chat with it. I can set up questions, say, hey, please monitor our app, our health endpoints, and it'll set up an agent for us to do that here. So we can manage our incidents in any of our current platforms. We've got PagerDuty, Azure Monitor, ServiceNow, whatever you're working for in your system, like for that, so we can set that up. We can set up response plans, and I've set up my Octopets response plan, of course, right? So we can set it up for all incident types. I'll hit next.
So when we first started building this, we built it for our own SREs that are working on our Azure services. And what we did is we took the guidance that we had for those SREs and we kind of codified it into an agent. And that's basically what you see here is kind of the realization of that.
Correct. So we'll look at our plan again. We got to hit a little refresh, no problems. Next here, and we'll hit skip. So here's our instructions that we're going to put in our execution plan. So basically, if you or I got called and something went wrong, what are we going to do? We're going to follow a set of steps to see what happened. Check this, check our scaling, make sure the network cable's plugged in, right? Stuff like that. So if you can type your execution plan out in a run book, you can basically set up these agents. And that's what we've done here. So I'm just going to scroll through somewhat quickly, because the most important part is here, hey, maybe we can check these particular commands, see if we've got some CPU or memory issues that we've got going on. You know, I'm going to tell my agent, my actual person agent, go check this out.
Your actual SRE.
My actual SRE.
Yeah.
Did you check for 500s? Things like that. If you find some drift, check these here. Check our bicep configuration, right? In the end, let's go ahead and create a GitHub issue that we can go and handle ourselves later on. Maybe engineers will have to go look at that. So that's exactly what we've done here. We've set that up on how we respond to those things. Now, the good thing is our SRE agent knows all about our resources. We've tied it to what's been deployed. It knows about the Azure resource groups. it actually knows about where our code is, so it can scan all that, has a tons of knowledge to use in order to find out what's happened. So if I look at our incident management here, look at that. Crazy enough, we have a ton of things going on here. Looks like it's triggered some 500s. Let's expand this page here. And this is kind of an audit of everything that's happened that as it's been checking for what are we actually looking for in our runbook? Checking our CPU.
It's kind of like an incident management log, basically,
Totally.
doing kind of the first line of investigation. But it's also interactive. You can
Right.
you can ask it questions.
And it's not doing anything magical. We don't want magic happening here. It's actually logging all of this exactly where we want to go and look. What did it try to do? What did it find? It says, look, we're finding out of memory exceptions, right? It's trying to do some things that we asked it to do. Try and set up, look at our subscription. Try and do an automated resolution by increasing our CPU. If it can or cannot do that, it'll continue to log this. And what we wanted to do is respond as we said to do. Can you go please log an issue for us so we can go look at it? Well, cool, look, it found this. Now it's going to do this log on behalf of Kay, who happens to be our actual SRE person here, but it tags it with a nice little SRE agent created, so we know this was in fact automated. So this is great. So now it's gonna give us what did it find, what's some of the errors that we've got going on here. It's nice and detailed, more than probably my agent might type in, like there's a problem. So we have some proposed code fixes here, some IAC drift, which is great. So what I'm gonna go do is go look at this issue, some other issues that we've got going on, and what I might wanna do, what would you do? I would assign this to Copilot, right? Now, we've got some custom agents also assigned here, and I've created an SRE follow-up agent.
Oh, awesome.
Right? And what this means is I've told it in my custom instructions here is just address what's been filed. Don't try and fix some CSS problem, which probably might exist, but just focus on what's been reported here, and I'm gonna go ahead and assign this off to Copilot. It's gonna go and do its work, which is great. It's exactly what I wanted to do, and then see if you can go and find the problems. Now, I'm gonna go and look at one that we have done in the past when we were setting this all up, and it's gonna create our pull request. So we'll go look at one of those, and let's go ahead and look at this one here. And you'll see it did find some issues here. Look, we've got this right here. This is the coolest thing. Right? So, we want to go forward.
Oops.
We've got
Zoom
little
out.
zoom issues here.
Yeah.
Sorry about that, guys. Let's go back here. So what we've got here is, it said we have our min and max replicas. It's set to 3 1/5 so we can scale. If you've used our Octopus app, sometimes when we click on it, it says it's having a hard time loading. So we have some scaling issues. This was previously unset. It was only going to 1, right? So it fixed that, and it also found some code fixes here. It was allocating some memory problems, which is really cool. Now, the cooler part is, if we go into view session, we can actually see what Copilot was actually doing here. It's gonna load the actual work. You'll see here, it made those changes in our configuration. It's gonna do that as proposed. We look at the actual details here. Let me scroll to the top. Magical. It's using our Azure MCP server that we've got configured. It's also using Playwright. You can do it before and after snapshots to make sure that we're good. And it's also using the GitHub MCP server to make sure that it can kind of back channel the reports back into our repository.
So it's both fixing the problem, it's addressing it in config as code, it's testing the solution using Playwright as well, and then kind of giving you the full fix.
Right, all in a single place, using all the same tools that we've been using both front end and back end.
Super awesome, Shayne.
Great.
Thank you.
Thanks.
All right. So the Azure SRE agent really automates incident management and resource optimization, and it reduces the pager alerts, and it proactively diagnoses and mitigates the issues that you might have in your code. It helps you automate deployments and rollbacks, and it continuously monitors resource health. And it is an incredibly valuable tool to help you drive platform engineering across your entire team. Now, in 30 minutes, we've used natural language specs and MCP to boost productivity at the start. We incorporated multiple coordinating AI agents to handle complex tasks within our apps. We monitored, we traced, we guarded those AI systems in the wild, and we leveraged AI to actually help manage our own app in production. This is really kind of the rise of AI agents, and it's driving a significant shift in the developer mindset and workflow. Traditionally, software development focused on writing code and managing infrastructure. Now the emphasis is on aligning your human intent with these autonomous systems. And developers are transitioning from prompt engineering to spec-driven development, where you have clear, testable specifications that guide the agent behavior. In this world, the most valuable developers are those who can articulate the intent really effectively, and they can enable the agents to execute those tasks with precision. As the agents take over all of these routine coding tasks that are mundane and tedious, they're not the kind of work that you enjoy doing anyways, you can actually shift your focus to think about more of the higher level problem solving, the strategy, the fun stuff, the fun aspects of your job. And that's what's really going to reshape the role of developers, making you all orchestrators of these intelligent systems instead of mere coders. This is not the future, what we just showed you. This is all real. This is today. This is how we code now. So check it all out. Go back, deploy your new agents, and get back to the joy of building. And if you want to learn more, here are a few more sessions that we'll have at Universe over the next couple days. Thank you.